Okay, so we're going to look at some geometric transformations here. So this is where a little bit of matrices manages to seep into some geometry. For each of these problems, we're going to draw a unit square, right? And then we're going to look at where does it expand to. So the first one asks me simply to make a reflection over the x-axis. So if I reflect this over the x-axis, I just get the square there. So this would be like in the original, this would be A, B, C, D. The new locations would be A prime, B prime, C prime, and D prime. All right, so let's look at number 2 here. Number 2 starts with the unit square again, right? Which is A, B, C, and D. Okay, and then what we're going to do is we're going to reflect this over the line y equals x. So A is staying put. It's going to be A prime. C is going to stay put. It's C prime. But D becomes B prime and B becomes D prime. So yes, the square stays in the exact same location, but it flips over that axis. So the D and the B would be in different locations. All right, so let's look at number 3 here. 3, they give me a a matrix or a linear transformation that explains it, right? So I want to start with my original unit square here, right? So this is A, B, C, and D. But then what happens is I'm contracting over the x, right? So the x is now half x, so B prime is going to be here, C prime is going to be here, A and D are not moving because their x's are 0 and half of 0 is 0. So the contracted rectangle will be there. Let's look at number 4. 4 is also doing a contraction, so I want to start with my square being big. There's A, B, C, and D, and now my contraction is going to be 1/4 of the y. So the A stays here. This is A prime, B prime, C prime, and D prime. So this would be the contraction that's expressed in number 4. Let's look at number 5. All right, in 5, we're doing an expansion, so we probably want to start with our square being small, A, B, C, D. We're going to expand the y direction by 3. So this is going to make my expansion this way, right? So I'm going to end up with A prime. So there's my new rectangle is there. So there's A prime. B prime doesn't move. C prime moves up here, and D prime moves up there. So that's number 5. Let's look at 6. 6 is going to be an expansion in the x direction. So here's my little square here. A, B, C, D. 1, 2, 3, 4, 5. So I'm expanding by a factor of 5 in the x direction. So the A stays put, B prime comes out here, C prime is there, and that's D prime stays put. Looking at number 7, we get into this thing that we call shear. So in 7, we're starting with our little unit square here, A, B, C, D. We're doing a shear so it's x plus 2y y, right? So the y values are all going to stay the same. A is at 0, 0, so that's not moving. That's going to stay right where it is, and A prime is going to land there. B is at 1, 0, so this is going to be 1 plus 0, so that's going to stay where it is. C is at 1, 1, so this is going to be 1 plus 2 is 3. Let's make 3 there. 3. So C prime's hanging out here. And D is 0, 1, so this is going to be 0 plus 2 is 2. So the segment DC moves out there. The A and the B stay the same. So you basically get that parallelogram there. This is number 7. Let's look at number 8. Okay, problem 8 is, instead of a horizontal shear, we're going to get a vertical shear here. Right, so again, my little square here is at A, B, C, and D. This time the shear is described by x, y plus 3x, right? So 0, 0 doesn't move. So 0, 0 stays at where it is. This guy is, B is hanging out at 1, 0. So this is going to be still 1, and then the other one becomes 3. So there's 1, 2, 3, puts B prime up here. C is hanging out at 1, 1. So that's going to be like 1, comma, 1 plus 3 is 4, so that's coming up here. And then D is at 0, 1. So that is still 0, 1. So that's D prime. And that's kind of an ugly drawing there. Let's fix that a bit. There we go. And you get a parallelogram going that way off that shear. So that's problem number 8. So let's look at 9 through 14 here. Okay, so we have to look at what's being described in these. If you look at number 9, the only thing that's changing there is the horizontal. So this is an expanding horizontally by a factor of 2. Number 10, the only thing that's shifting. So in 10, there's actually, this is an example of add, multiply and add. So this is actually going to be a shear. And it's a vertical shear. Oops. So this is a vertical shear by a factor of 5. Number 11 is, sorry, that's a factor of 2. Number 11 is going to be a horizontal shear by a factor of 5. Okay, number 12 is a contraction. And that is a vertical contraction. And that's by a factor of a half. Number 13 is a reflection. And that's over the x-axis, right? Because we're changing the y. And then we're going to expand once we're over that axis by 2. And then 14, you're going to reflect over the y-axis, and you will expand. Sorry, not going to expand. This is going to get smaller. You're going to contract by 1/4. Okay, so if you're unsure about any of these, actually try drawing a unit square and see what happens when you multiply the vertices of the unit square by the matrix that you're given, and you should see these results come out. All right, so there you go. That's geometry and linear transformations.